Bonjour, my name is Alex Lim, your JC H2 Math tutor. What happens when there are no real roots? What is meant by no real roots? No real roots simply means that when you have the discriminant b squared minus 4ac is less than 0, or if you use the cross method, you can't find a real number to get the root itself. There is simply no real root. In other words, the roots are imaginary, and you'll learn that in complex numbers in the future. Right now, let's just focus on the fact that there are no real roots. So what do we do? Usually, if there are no real roots, the first thing we can think of is completing the square. We always want to complete the square because the whole quadratic expression could be positive or negative. Completing the square becomes a very useful tool which we will go through later on in our example. You'll see it for ourselves how we go about doing it. An alternative method is to use the discriminant method. As mentioned, when there are no real roots, b squared minus 4ac is less than 0. That is the discriminant. Okay? If you're curious to know what happens, the general formula for finding the root of a quadratic expression is minus b plus minus square root b squared minus 4ac over 2a. So when whatever is in the square root, which is b squared minus 4ac, is negative, you can't square root a negative number. In mathematics, that doesn't make sense. You can only square root a positive number, not a negative number. That means that there's no real root. So what happens? In other words, you can say that the roots doesn't exist, and there are two cases that splits out from here. If a is positive and b squared minus 4ac is negative, what does it mean? When you have b squared minus 4ac less than 0, it really means that the curve doesn't touch the x-axis. And when you have a smiley curve, it means that the whole graph is positive. So ax squared plus bx plus c, the whole quadratic expression is positive. Similarly, if a is less than 0, and b squared minus 4ac is less than 0, yes, the curve doesn't touch the x-axis, and most importantly, a is negative. So the whole expression is going to be negative because the whole curve is negative, it's below the x-axis. So ax squared plus bx plus c is negative. So just to briefly conclude this part, there are two aspects of solving a quadratic polynomial. The first part is when there are real roots. The second part is when there are no real roots. If there are real roots, we always try to factorize by using the cross method of completing the square. If there are no real roots, we complete the square to show that it's positive or it's negative, or we use the discriminant method and draw the graph to determine the whole curve is positive or negative. In general, if you are given a quadratic expression, you don't really know if it's positive or negative. So what do? You try and error. You can try the cross method first to see if it's factorizable. If not, you go to completing the square. If not, you can go directly into finding the b squared minus 4ac to determine if it's factorizable or not right from the start. It's all up to you and your personal preference. For part D, we will have negative 1 minus x times x minus 1 square more than or equals to 0. What are the roots? The roots are, if you substitute here, if you substitute 1, answer you'll get negative 2. So actually it's negative 1. Over here the root will be 1. So the roots are minus 1 and 1, arranged in ascending order. Now, how do we sketch the curve? We look at the term in x cubed. X squared term is here, but here there's a minus x. So, the term in x cubed is negative x cubed. So coefficient of x cubed is equals to minus 1. So the curve looks something like this. From my experience, I know that the turning point occurs at 1. Why? Because the power of x minus 1 is 2. So the curve will look something like this. Okay, the curve, I repeat, no longer intersects 3 points at the x-axis. It only intersects at 2 points. The only possibility is this, or this, the red curve. But the red curve isn't what we want because the turning point occurs at 1 since the power of x minus 1 is 2. So I'm going to erase the red curve. Alright, so this region is plus, minus, minus. Alright, you can use the battery method again just to illustrate to you one last time. For the battery method, there are 3 regions. In the first region, substitute a number, maybe negative 2, inside the cubic expression and you'll get something positive. And then, at the root negative 1, you are looking at this factor. The power is 1, so the sign will alternate from plus to minus. Then, at the root 1, this is the factor now, and the power is 2. So the power remains the same on the left hand side and on the right hand side of 1. So, plus, minus, minus. So which region do we want? We only want the positive region. This is the region. So the answer is x less than or equals to minus 1. But take note, is this the answer? If you think that this is the answer, then you have missed out 1 point. The point is that it can be equal to 0. Which part of the curve does it touch the x-axis so that we get a 0? It's actually this point, your 1. So x can be 1 as well. Okay, so we need to add this point, which is important. What does this mean? This means that whenever we have a question like this, we do not throw away x minus 1 squared term. We do not throw away x minus 1 squared term, or x squared term, or x plus 3 squared term. We only throw away these terms when we have x squared plus 1. Then we can safely say that it's positive and we can remove it. But if it's strictly x minus 1 squared, it is more than or equals to 0. We do not throw away the term just because it's positive. We keep it there just in case. Because if we throw away that term, we will miss out x equals to 1 as the solution. Then we will have one less solution. Alright? So take note, do not throw away x minus 1 squared term. We can throw away x squared plus 1 but not x minus 1 squared. Alright? This is something for you to take note. Just be careful. So what are the roots again? I'm sure you know by now. The roots are a, b, c, where a is less than b, less than c. Now, you look at the coefficient of x to the power of 4. X times minus x times x squared. What is my term in x to the power of 4? It's actually minus x to the power of 4. Do you agree? It's because of this minus sign over here. So, what is the coefficient of x to the power of 4? It's actually negative 1. So, the curve will look like a M shape. Once again, if you try to fit the m like this, you realize that it doesn't really fit because there's a missing intersecting point. There's a missing root. So the reason is because one of the root is actually a turning point as well, just like the previous example. Which root is that? It occurs when the factor has a power 2, which is root c. So I'm going to draw it like this. So this is minus, plus, minus, minus. Do you get it? So, which region of the curve do I want? Positive. So it's only this. So, x is between a and b, including a and including b. But since it can also be equal to 0, which point, where else does it touches 0? This point, at root c. So we need to include x equals to c. What does this mean? X minus c squared, do not throw away just because it's positive. It's not strictly positive, so technically we shouldn't throw away. Alright? So this is the set. So the set taking all real numbers such that x is between a and b or x is equals to c.